Hi, my name is Daniel. Welcome to the Success Classroom problem solving video. This video presents 5 questions on the physics topic, kinematics. Without further delay, let us begin to problem solve. Question 1. A boy throws a ball vertically upwards with a speed of 10 meters per second. What is the acceleration of the ball 3 seconds after leaving the boy's hand? Now, as the ball is being thrown vertically upwards, it is constantly subject to gravitational acceleration, or in this case, gravitational deceleration. Okay, and the value of gravitational acceleration is 10 meters per second square. So we're looking at 10 meters per second squares, and because gravity is acting downwards, so the acceleration in this case will always be downwards. Answer is C. Question 2. The diagram below shows the speed time graph of a bullet train. What is the train's acceleration in the final 30 seconds? So if we look at the final 30 seconds, okay, for a speed time graph, take note that gradient represents acceleration. Okay, so what we need to do is to determine the gradient of this line. Alright, so to determine the gradient of this line, we will have to take rise over the run. So the vertical column here is 200 meters per second. Okay, so to get the acceleration, you'll take 200 divided by 30, which is equals to 6.7 meters per second square. And because it's a negative gradient, downward sloping straight line, so we will add a minus sign in front to denote deceleration. Answer is A. Question 3. Kevin throws a stone vertically upwards from the top of a building. After traveling upwards for some time, the stone turns around, falls down, and hits the ground at the bottom of the building. For this motion described, which statement below best describes the velocity of the stone? Now if we draw a diagram to denote the motion of the stone, so it's being thrown up, then after that it's going to come down and hit the bottom of the building. Okay, in terms of the velocity time graph, okay, the stone will thrown up with an initial velocity, and then after which it will undergo constant deceleration, alright, constant deceleration, straight line, until it reaches the maximum point, which is the maximum height. Okay, and thereafter it's going to actually go this in the opposite direction down, right, until it hits the bottom of the building, which is at this point, at this time. Alright, so let's analyze 4 options. When I look at the 4 options, option D, the velocity of the stone is constant. This is obviously wrong. Okay, the velocity is not constant. The stone is undergoing constant acceleration or deceleration in this case. Option B is also not correct. As the stone is moving up, the velocity of the stone is not increasing. It's in fact decreasing. Okay, so B is also wrong. That left A and C. Now we look at option C. The velocity of the stone decreases, then increases. Now, if we look at the stone, when the stone is moving upwards, we can say that its speed is decreasing. Okay, speed is decreasing. And then when it's coming down, we will say that the speed is increasing. Okay, it's increasing. So if we look at option C, if the velocity is speed, okay, if this says that the speed of the stone decreases, then increases, then option C is correct. But in this case, we are talking about velocity. So C is not the answer. So that left A being the best answer so far. The velocity of the stone decreases. This is because if you look at the velocity time graph, right, while the stone is moving up, the velocity is decreasing, okay, decreasing. While it's actually falling down, it's going down into the opposite direction, right. In terms of vectors, the velocity is also decreasing. So A is the answer. Question 4. At time t equals to 0 seconds, a stone is thrown vertically up into the air at 20 meters per second. Which of the following best describe the motion of the stone in the air at t equals to 2 seconds? Now, in order to answer these questions, what we can do is that we can draw the velocity time graph of the stone. Okay, when a stone at 0 seconds is being thrown upwards, it has an initial velocity of 20 meters per second. And while it's moving up, it's subjected to gravitational deceleration, so the velocity of the stone is decreasing constantly until it hits the maximum point, alright, which is at this time. Now to get the timing at which it hit the maximum point, what you need to do is to make use of the gravitational deceleration value of 10 meter per second square with the initial velocity of 20. So what we have is that we have 20 and then we divide by t, and this will give us 10. Okay, so t is actually 2 seconds. So this is 2 seconds, which corresponds very nicely with the time given by the question. In other words, at time t goes to 2 seconds, the stone will have reached the maximum height. Right? When it reaches a maximum height, the stone will remain momentarily at rest, so the speed is 0 meter per second. And because the stone is constantly being subjected to gravitational deceleration, so the magnitude of the acceleration is going to be 10 meter per second square. So the answer for question 4 is D. Question 5. A girl takes 90 seconds to walk 80 meters towards the north, and she runs 60 meters towards the east for 10 seconds. What is the average speed and average velocity? Okay, to calculate the value of the average speed, average velocity, we can actually draw a simple diagram to show the movement. Assuming that moving up is north, okay, so she moved up 80 meters, and after that she moved east, right, for 60 meters. Okay, so to get the average speed, what you need to do is to take the total distance, divide by the total time of 90 plus 10, and this will give us 1.4 meter per second. Now to get the average velocity, what we need is actually the displacement. Okay, we need displacement. Alright, so this is a Pythagoras theorem. So you can make use of Pythagoras theorem. So right angle triangle, so it's 80 meters, 60 meters, this will give you 100 meters. So to get the average velocity, you take the total displacement, divide by the total time, and that will give us 1.0 meter per second. So if you look at the answer, you will look at 1.4 meter per second as well as 1.0 meter per second. Answer is A. That is the end of the video. For more details about my problem solving videos and tuition services, please visit thesuccessclassroom.com. For any feedback or comments, please feel free to send me an email. My name is Daniel. Have a nice day. Thank you.